Hello everyone, this video is about our project Load Flow Analysis by Newton-Raphson method under the course Power System 1 Laboratory here in Bangladesh University of Engineering and Technology. So what is load flow? Load flow study is the steady state analysis of power system network. Load flow study determines the operating state of the system for a given loading. It solves a set of simultaneous nonlinear algebraic power equations for two unknown variables V and delta at each node in a system. To solve nonlinear algebraic equations, it is important to have fast, efficient, and accurate numerical algorithms. The output of the load flow analysis is the voltage magnitude and angle, real and reactive power in both generation and load sides, line losses, and slack bus power. We have done this project using Newton-Raphson method. Now, what is Newton-Raphson method? In numerical analysis, Newton-Raphson method is a root finding algorithm which produces successively better approximation to the roots of a real valued function. We have done this project in MATLAB. Now, if we look at the codes, here we have created several functions to run the program. This is the main code which I will run. It will ask the user for the number of buses to analyze load flow analysis conditions as per given data. You can see that we have called a function ybus, which is basically a function to determine the admittance of the system. It takes information from the function called line data, in which we have information about the line. It then calculates the elements of the ybus matrix. Another function we have created is Newton-Raphson, which takes number of buses, admittance of the system, bus data, and bus MBA as input to initiate the calculations. This function then calls another function named bus data, which takes bus information for the selected bus number system. Then the real and reactive power is calculated using mathematical formula. We have written code to determine the Jacobian matrix also. At last, the state vectors are updated for a number of iterations. The next function is load flow, which calculates real and reactive powers and line losses. At the end, it displays whole load flow analysis. This is the bus data function. We have taken data for various number of buses. All these data are IEEE standard. Here we can see bus data for 4, 5, 6, 14, 30, and 57 bus systems. We have another function for line information for the same number bus system as bus data. Last but not the least, this small function pole to rect converts a complex number from polar to rectangular value. Now, if I run the code, you can see that MATLAB asks me to select the number of buses I want to continue the load flow analysis for. If I type 5 and press enter, you see the Y bus matrix evidence for the whole system. This is the Jacobian matrix we have got. This is the whole load flow analysis. We can see for a 5 bus system, voltage, magnitude, and angle, injected real and reactive power for both generation and load sides, line flow from one bus to another, and line loss can be seen here. This is the graphical representation of the voltage magnitude and angle for each bus of a 5 bus system. We can do this whole process again for another system. This is what we got for a 6 bus system. What if we do this for the 57 bus system? This is the voltage magnitude and phase for the 57 bus system. Now, how are you so sure whether we are doing it right or wrong? To verify this, we have taken data for a 4 bus system from the book Power System Analysis by John J. Granger and William D. Stevenson Jr. Here is the line data and bus data for the 4 bus system which we have taken as input. If we run the code for a 4 bus system, we see for bus 1 voltage magnitude is 1 per unit and angle is 0 degree. For bus 2 it is 0.9824 per unit and minus 0.9761 degree. For bus 3 it is 0.9690 per unit and minus 1.8722 degree. And for bus 4 it is 1.02 per unit and 1.5231 degree. Now Look at the answer from the book's problem. From this comparison, we see that the values determined by MATLAB are quite approximate with the ones in the book. So we can say that our code works successfully. That's all for today. Thanks for watching this video. Hope you enjoyed it. If you have any query, you can leave a comment below or send us an email. The link is given in the description below. Thank you.